Well, welcome back to Mr. Flores's Algebra 1 final review videos to help you guys out, because I care. So, if you look at this video is going to be using Chapter 7, solving a system of equations, and specifically it's going to be used for solving a system of equations using elimination. Now, some other words that mean the same thing as elimination are to get rid of, to make go away, to disappear, to eliminate. So obviously I'm not an English teacher, but in mathematics, those all basically mean make something or a number go to zero. So we need to eliminate either the x's or the y's, and it'll make our life a whole lot easier. So if you look here, we have a 3x and a 2x. No matter what we do, whether we add 3 and 2 or subtract them, we can't get 0. But what's nice about this problem, if you look over at our y's, that's a negative 5y and a positive 5y. We can add everything together in these equations, and the y's are going to cancel. The biggest thing here is when you add the equations together, always combine like terms. So if we have a 3x and a 2x and we are adding them, that is going to become a 5x. Negative 5y plus a positive 5y becomes a 0y. I'm not going to write it because, well, 0. But then when you add negative 16 plus a 31, we are going to get 15. Sorry, I couldn't think for a second. So now we get 5x is equal to 15. Divide both sides by 5. And x is equal to 3. It's nice. It's easy. It helps us out. Now, we found x, and just like in substitution and graphing, if x is equal to 3, in order to find y, we can just substitute a 3 into either equation. No matter which equation you use, you will still get the same answer. I'm going to substitute it into the first equation, so it becomes 3 times 3, because it was 3 times x, minus 5y is equal to a negative 16. Simplify, 3 times 3 is 9, minus a 5y equals negative 16. Subtract the 9, boom, disappears. We get negative 5y is equal to negative 25. Now in order to get y by itself, since it's negative 5 times a y, obviously the inverse of multiplication is division. We're going to divide both sides by negative 5. It's going to go away. And y is equal to positive 5. Negative by negative, positive number. 25 divided by 5 is positive 5. And our solution set is 3, 5. And that's your answer. Likewise with substitution and graphing, if you substitute a 3 in for x, a 5 in for y, both sides of your equation will match. They'll be equal. So that is the easier of the type of elimination problems. The harder kind, but it's really not hard, it's just an extra step, is one that looks like this. Let me find one. Alright, so we have 4x minus 3y is equal to 12. Then we have x plus 2y is equal to 14. Now again, we need to eliminate one of the variables. This is a 4x, this is a 1x. Since there's nothing, it's a 1. Then we have negative 3y and a positive 2y. If right off the bat, unlike in the last problem, the coefficients of the variables don't match. A 4 and a 1. Alright, so this is the second type of problem we are going to solve using elimination. But the glaring difference between this problem and the previous problem is that none of the coefficients for x's or the y's match. It's really not a big deal. We can easily solve this. So we need to find a common number between 4 and 1 or a common number between 3 and 2. I'm going to find the common number between 4 and 1 because it's just easier. It's only one multiplication step. So the common number between 4 and 1 is 4. In order to make a 1 become a 4, we need to multiply by 4. Now, in order to make this equation stay true, we must multiply 4 by every single term in the equation. So it's going to become 4x plus 8y is equal to 60, what is that, 56? Okay. Now I'll rewrite the original equation from the top. 4x minus 3y is equal to 12. Okay. So now we need to notice that both of our x's have a coefficient of 4, but they're both positive. The way to make two positive 4s eliminate or go to 0 would be to subtract them. Since we subtract the 4x's, we are subtracting everything also. 4x minus the 4x is 0x. Negative 3y minus 8y is negative 11y. 12 minus 56 is negative 44. Now we have negative 11y is equal to negative 44. In order to solve for y, we must divide everything by a negative 11. And y is equal to a positive 4. So now that we know that y is equal to a positive 4, just like every other type of system of equation problem, we can substitute this 4 into either equation for y and solve for x. Does not matter which equation you use. I'll use the top one since the numbers are smaller. And you're going to have 4x minus 3 times 4 is equal to 12. Simplify, we get 4x minus 12 is equal to 12. Something nice will happen here. We have to add 12 to both sides. We get 4x is equal to 24. Divide both sides by 4. And you get x is equal to 24 divided by 4 is 6. So our nice solution for this one is 6 comma 4. And again, if you don't trust me, which, hey, I make mistakes, take the 6, substitute in for x, take the 4, substitute in for y, and you will get 12 as your answer. Or if you do the other equation, you'll get 14. But it doesn't really matter. Your answer is 6 comma 4. Okay? Now, the hardest the hardest elimination problem is one that looks like this. Alright, so this is the third and final problem I'm going to do for elimination. Now, the nice thing about elimination is, well, things get eliminated. But the not so nice thing about this problem is that it is the hardest one we're going to do. So, right off the bat, we see that we have a 3x and a 2x, a 4y, and a negative 3y. No coefficients of x's or the y's match. So in order to eliminate one, we need to manipulate them. So I want to say we're going to eliminate the x's. In order to eliminate that, we need both coefficients to be the same. We need to change the 3 and the 2 to be a common number. The easiest number that I can think of that has a 3 and a 2 as factors is 6. Now in order to make this 3 become a 6, we need to multiply by 2. In order to make the 2 become a 6, we need to multiply by 3. Just like in the last one, when we multiply the number or distribute it in, we multiply. So don't forget that. You're going to get a 6x plus 8y is equal to a negative 50, and 6x minus 9y is equal to 18. Now, if you notice, nicely our x's match, they're both a 6. So since they're both positive 6, in order to make them eliminate or go to 0, we need to subtract the equations. 6x minus 6x is 0x. I'm not going to write it. 8y minus a 9y gives us a positive 17y. Then negative 50 minus 18 gives us negative 68. I meant this is a positive 17y. I think I said negative. So now we have 17y equals negative 68. To get y by itself, divide both sides by 17, and you're going to get y is equal to negative 4. Because 16 divided by 17 is 4, and there's a negative outside, so it's negative 4. Now, the thing with this problem is, in order to substitute this 4 back in, we need to put it in one of these equations. And it doesn't matter which one, just like all the other problems. It doesn't matter which one we put it into. We will still get the same answer as long as we do all our math right. So what I want to do is I'm going to substitute this negative 4 into the top equation. So we're going to get 3x plus 4y times a negative 4 equals negative 25. So you're going to get 3x minus 16 equals negative 25. Add 16 to both sides, and you get 3x is equal to negative, oh, that's a 5, not a 9. And you're going to get negative 9, divide both sides by 3. You're going to get x is equal to a negative 3. So our solution set for this one is negative 3 comma negative 4. Okay? That's your answer. That's it. Just like the other ones, you can check it if you want to make sure I'm right. And like on a test, make sure yourself is right. But that's the answer for this one. And we will do one more problem, which is going to be a word problem. So stay tuned. Alright guys, welcome back to the final exam review. This is the last thing I'm going to do for solving a system of equations other than graphing inequalities. But it's a word problem, so I know you guys hate it, but you're going to love it, I promise. So if we look here, we have a scenario where we're going to go to the zoo. We have one van that's carrying 2 adults, 5 students, and paid $77 to get in. The other van had 2 adults, 7 students, and paid $95. How much did each adult and student pay? Okay, so right off the bat, we know we're going to have 2 equations. The first equation is going to be our van number 1. Second equation is going to be van number 2. Now, just like every word problem, you need to identify what your variables are. And in this problem, our one variable is the adults. The other variable is our students. The easiest way to know that is look at the end of the word problem. You want to know how much an adult and a student pay. There's one variable, there's the other. Okay. I'm going to say adults can be X, students can be Y. So our first equation, aka our first van, had 2 adults, so it's 2x plus 5y because there's 5 students, and they paid a total of $77. Second equation had, again, 2 adults. This one had 7 students, and they paid a total of $95. Now, this one is set up nicely to solve using elimination. So what we can do is, right off the bat, eliminate our x's. Because it's 2x and 2x, no manipulation has to be done. Since they're both positive, we're going to subtract to eliminate them. 2x minus 2x, 0x. I'm not going to write it. 5y minus 7y is a negative 2y. And 77 minus 95 gives us a negative 18. Divide by negative 2. And y is equal to positive 9. Okay? To find our x value, same thing. Substitute back into y. You're going to get 2x plus 5 times 9 is equal to 77. 2x plus 45 is equal to 77. Subtract 45. Subtract 45. 2x is equal to, what's that, 32? Yeah. Divide by 2. Divide by 2. X is equal to 16. Okay. Now, if you want to write it as a coordinate, your answer is 16, 9. But since this is a word problem, we need to define what is 9 and what is 16. But if you remember from the beginning, we said that The adult is X, student is Y, so an adult is $16. Student ticket is $9. So, in order to get full credit for this problem, you need to give me $16 for an adult ticket, $9 for a student ticket, and that's it. Remember, word problems, always define your variables, and that's why it helps in the beginning to write down what they are so you don't forget. Okay? The next video we will do is solving a system of inequalities graphically. So, it's pretty easy. Stay tuned.